In this illustration, we'll discuss about a block sliding in a groove. Here the figure shows the top view of a horizontal disc in which there is a square cross-section groove XY is cut along a diameter, and inside the groove a block A of mass 1 kilogram is placed and disc is accelerated at 25 meter per second square in the direction shown. It is saying if the friction coefficient for all surfaces of groove is 0.4, we are required to find the acceleration of block A with respect to disc. Here to analyze the situation in the reference frame of disc, let's draw the forces acting on the block A. Say if this is the groove in the disc, and here if this disc is accelerating toward left with an acceleration A, and here we can see the block placed in the groove will experience a pseudo force with respect to disc toward right, and that is MA, mass of block A multiplied by the acceleration of its frame. Its weight mg will act in inward direction because we are looking at the top view of the disc. Now in this situation here we can see if this angle is theta, here also this theta which is 37 degree. So here MA cos theta is the force acting on the block A with respect to disc, which is responsible for its sliding along the groove. Now due to this it will experience one friction at the base of disc, which is F1, and another friction is on this right surface of the groove, where due to MA sin theta the block will push the surface, and a normal reaction is developed which is N over here, and when this block will slide due to MA cos theta, a friction will also act on the block which is F2 on the side wall of the groove. So here we can say during motion there will be two frictions acting on A. First would be at the base of groove, and this friction F1 we can write it as mu mg, because normal reaction in vertically upward direction opposite to mg will be mg only because it is balanced by the weight. So this friction F1 which is acting at the base of groove would be mu mg. If we substitute the values, the 0.4 multiplied by mass is 1 g, we can take as 10, so this is 4 Newton. And the second friction is acting at side wall of groove, which is F2, and this value will be mu n, and normal reaction on the side wall we can say with respect to disc will be equal to MA sin theta. So this will be mu times MA sin theta. We substitute the values numerically, mu is 0.4 multiplied by 1. Acceleration of disc is given to us as 25. Theta is 37 degrees, so here the value of sin theta will be 3 by 5. And this 5 gets cancelled out. Now simplifying, this value will be 15 multiplied by 0.4, this 6 Newton. So these are the two frictions acting on the block, and the sliding force responsible for sliding in the groove is MA cos theta with respect to disc. So we can write here if acceleration of A with respect to disc is A1, this implies we use the equation of motion as MA cos theta minus F1 minus F2 is equals to MA1. Here the value of MA cos theta we can calculate as 1 multiplied by 25 multiplied by 4 by 5 minus 4 minus 6 is equals to mass of block is 1 kilogram. So this is E1. This implies on simplifying we'll get the value of E1 is, this is 5 multiplied by 420 minus 10, and that is 10 meter per second square. This is the final result of this problem.